In this video, we are going to see a combination of weak crypto and insecure direct object references. Insecure direct object references occur when an application provides direct access to objects based on user-supplied input. As a result of this vulnerability, attackers can bypass authorization and access resources in the system directly. For example, database records. In case of our secure store APIs, view profile endpoint is susceptible to insecure direct object references due to the fact that the endpoint uses user's authentication token as the key to retrieve profile information. And this token can be easily generated by anyone if they know the username of the victim. Let's see this in action. I'm switching to Burp Suite and I'm going to make a view profile request. As you can see, the request is successful and we have obtained valid response. If you closely observe the token passed in the GET request, it is of 32 characters length. It is also observed that it is constant across multiple sessions of this user. For example, if you replay the login request once again, you will get the same token. Let's try to log in once again. You are still getting the same token. That means the token is constant across multiple sessions. This means if the user signs out and relog in, the same token will be present for his authenticated functions. A quick analysis also reveals that this particular token is the MD5 hash of the user being logged in. To check that, let's go to decoder and pass secure store as input, and let's create an MD5 hash. If you notice, the hash starts with 2121, and if you go back to the repeater, the token also starts with 2121 and it ends with A0W. That confirms that the authentication token is generated on the server side by using the logged in user's username. That also means that if we can guess the usernames of other users, we can perform authenticated transactions on behalf of them. Let's see how we can do that. Let's assume that we have a user called attacker who is registered on this system and we don't know his password. Let's generate an MD5 hash for the username attacker, and this should be the MD5 hash. Let's copy this and I'm just removing the spaces. Now let's use this token and go to repeater and go to view profile endpoint and replace this token and paste the new token, and once again let's click send. As you can see, the modified request is still working and we are able to fetch somebody's user information. Essentially, there are two issues seen here. The first issue is lack of validation against who is requesting the information, which can also be called as missing access controls. Second issue is weak token generation, which allowed anyone to create other users' tokens and replay requests on behalf of them.